Synthetic division, synthetic division. Now, I've been mentioning this technique for the last few videos, but we still haven't got around talking to what it's really about, right? Which is what we're about to do right now. Now, the terminology for synthetic division, when we say synthetic division, that's a little misleading because we're not really going to be using synthetic division to divide polynomials together. We will for when we have a linear function in the denominator, and we will talk about that. But what we're really going to use synthetic division for is to factor large polynomials. Polynomials that are higher degree than degree of 2. Polynomials that are have more terms than 3 terms. So polynomials that aren't just trinomials, but they have 4 terms or 5 terms. Because as soon as you go beyond 3 terms of a polynomial, you have to go to a degree of 3 or a degree of 4, more than a degree of 2, right? Because if you have a trinomial, it has to be degree 2, degree 1, and a constant, right? Degree 0. As soon as you go to 4 terms, your first, the largest term, has to be degree 3, and then degree 2, and then degree 1, and then degree 0. If you go to 5 terms, then you start off with a degree 4, right? Because that's, you set your, for polynomials, you set your degree starting up with the highest degree first and going down, right? To learn this technique, what we're going to do is talk about long division. We're going to do a couple of long divisions of using synthetic division, and then we're going to put the long division of polynomials aside and just attack polynomials, large polynomials, and try to factor them using synthetic division. So when we talked about dividing polynomials, when we did polynomial long division, basically we had the following types of equations, right? Following types of expressions that we had to do. For synthetic division, what we're going to specifically work with is the top could be any degree, okay, but the bottom is going to be degree 1. Now we can factor, we can use, or we can do division, synthetic division for polynomials. There is a technique for it, to do synthetic division for polynomials where the degree in the bottom is higher than degree of 1. But we're not going to go there, right? Because I personally never ended up using it. And if you do get some expression like this, when you have to divide 2 polynomials together, then you're just going to use long division if your degree in the bottom is higher than degree of 1. So what we're going to focus on for synthetic division is division of the following form, where the denominator is just x minus a, and a is a constant, okay? So this is what we're going to use synthetic division for. And if you recall, all this means, if you have x minus a in the denominator, what you can do is just set that equal to 0. And what you do, you bring the a over. So what you're doing is checking to see what your function is equal to when x is equal to a. So what you're doing is solving for f of a, and then finding out what your answer is, which becomes your, when you do your division, it becomes your remainder, right? And we talked a lot about this in doing polynomial long division. One thing to keep in mind, and this is the first thing we're going to start talking about, is what you should be really careful of, because in most things you look at, most of the time that we're going to do this is it's going to be x minus a. It's going to be the coefficient in front of the x is just going to be a 1. However, you can do synthetic division where the coefficient in front of the x is not an a. It could be, it's not 1, but it could be another number. It could be 2, it could be 3, it could be any other number. So we can do synthetic division for expressions where we have another number in front of the x instead of a 1. So we can do synthetic division for the following. If we have something like this, bx minus c in the denominator here, we can still do synthetic division, but there's a trick to it, okay? Now, let's just lay this out. The way it works is, all you do, you set this equal to 0, and then bring the c over, divide by b, and all it ends up being is your a becomes a fraction, right? So what you end up having is, I had to do it this way because I went off the camera, but what you end up having is x is equal to c over b, right? And your a term here would just be a fraction. It would be just x minus c over b. In general, we're going to do synthetic division when it's just x minus a in the denominator. Okay. If we get anything else, a higher degree down here, we're going to use polynomial long division. And in general, if we get a expression like this where we have this thing in the denominator, we're still going to use polynomial long division. Where we are going to use synthetic division for is not necessarily for polynomial long division. We're going to use it for factoring large polynomials, polynomials that are higher degree than degree of 2. So let's go take a look at the special case here where, we have this type of expression in the denominator, and, make it a point to show you what it is that you have to watch out for and how things change when you write it, move things over and you write it as a fraction where your a is really just your c over b, okay?